The objective today is to calculate a network ID given a subnet mask and incoming IP address. So of all my subnetting videos, this one is my absolute favorite. We get to take everything you learned from the other videos and then put some code to it so you're really seeing what's going on at the lower level. And in the beginning of this lesson, a lot of my information is going to come from this website, which Microsoft does a terrific job, in my opinion, of giving us this like support.microsoft.com stuff. If you just type that in and start browsing around, there's a lot of useful information on that site. Oh, and that's why I did the little deep diving guy, because it's hard to maintain focus when you go to sites like that. And speaking of deep dives, after this lesson I want you to do some deep thinking on what I covered and do some deep breathing just to let those details that you see here in the table of contents, there's so many details I'm going to throw at you. You'll need some deep breaths to get through it, I think. But when you come out on the other end, if you're like me, you're going to be so happy that you understand subnetting. It is such a complicated thing. I looked everywhere for help, and at the end of the day, I just had to piece together many helpful people to actually feel confident in my knowledge of subnetting. So table of contents, we have a nice intro with the purpose of subnetting and then those details I told you about. Then we get to dig into the code. Absolute funnest part of the lesson. After that, I just want you to practice a little bit so you gain that confidence. So here's the purpose. In a picture, this is the purpose of subnetting. Back in the old days, we had classes A, B, and C. People still refer to these all the time, but what this drawing is, this is the entire internet, okay? Pretend like this is all the IP addresses that can exist. And for the internet, for a network of people to communicate one to another, we need to have very unique addresses so the person can speak to the exact right person that they're trying to speak to. When you go on Facebook, you're looking at very specific people or groups, and you're all comfortable with sharing with each other because you are on the same IP address, one of these Facebook IP addresses. That's kind of the cool thing about social media, is it's like that is the meeting place. You've all met up at that one location. And if you want to spend time apart like people do in real life, you spend time apart. You don't go to that meeting place. And it is a place. It's not actually in your hand on your phone. It's more like your phone is a window to that place that is somewhere probably far, far away from where you're actually located. So anyways, this is the whole internet. At first we divided it up into 3 classes. This is for the large networks, medium-sized networks, and small ones. But a problem started to happen. The small networks, sometimes a small business owner, might need a longer range of IP addresses. So instead of buying 3 different Class C networks, we could just subnet and expand the size even though the IP address starts with a Class C IP. Here's what those ranges look like. All Class C IP addresses are supposed to have a 192 in their first octet, or any number in between up to the number 223. So anyways, sometimes networks need to expand, sometimes networks need to shrink. Maybe a successful company with a very large network just doesn't need all these extra IP addresses. So by communicating with Aaron, maybe they can get a smaller range and give these IP addresses they're not using anymore back to the pool for others. So in a single picture, like this is all of the internet back in the day when we had classes, and this is more like what the internet is looking like nowadays, each one of these representing a network. And think about this, after you've purchased a range of IPs from Aaron, you could always divide that range into a smaller network. Again, we call these subnets, so you can create 3 subnets from one subnet. Let's say you're a large company and you want all your marketing people on one network, all your sales people on the other, and maybe all the managers on the other. I mean, however you want to do it, you'll have that power as a network administrator. And it's not terribly hard to do. You just need to pretty much know the math behind it and not screw that part up. That's sort of what they're testing you on in these networking tests to see if you can get that part correct. So in your own words, what's the purpose behind subnetting? Notice I wrote in here with uneven octet boundaries, so we're not doing this anymore. So what's the purpose of doing it the way I just told you about? And a quick note on the term subnetting, I've heard it used to refer to either the idea, like the bottom of that picture right there, and I've heard it used to refer to the skill I'm about to teach you today. That is taking that number and putting it into this mathy thing and coming out the other end with a network ID. See, the big objective of today is network ID. Why do we need that? Well, because that allows us to figure out if an incoming packet is on a network that the router knows of or not. When I'm looking for a specific IP address, I'm not going to go to every single computer in the world. I'm going to just try to stop at the doorsteps of several networks to see if they have the IP address I'm looking for. And at one point it occurred to me, I was wondering, can I have two of the same IPs but with a different subnet masks? That goes back to what I said at the beginning of the lesson, where you can subnet a subnet. The short answer is no. Why? Because Aaron's not going to let you do that. Or if you do that, you're going to start breaking communication and things will not work right. You'll ask for something from a computer and it won't get delivered to that computer. So Aaron's not going to give out two of the same IPs in the first place. They're going to give you 1.2.3.4/8, and then if you want to turn it into this, you'll be able to. And if you try to go the other way, where they give you this maybe, well, what do you think will happen? See, this website, Server Fault, is a great resource. Part of my job as a teacher is to just try to set you up for some good journeys or exploration. So I'm not going to answer that one for you. I have to focus here. We're focusing on the network ID. So the question, what are you expected to do with an IP address? The answer is find a network ID from it. On one of those tests, you might be given a CEDAR address and you have to find the range, the network ID, and the broadcast ID. The broadcast ID is just so easy. You just take all the bits in the host portion and turn them into ones. Alright, so to do this, to find the network ID, it is super time consuming. I've seen a few tricks to help, like Professor Meiser. He uses this table, these two tables, to create what he calls a 7-second process. But those tables, you're going to have to memorize them or definitely practice with them in order for them to be useful or helpful to you. There's another way I've heard of called the magic number concept. Now, both of these things I will give my students in real life the videos to, but for the rest of you, if you're just random watching this, go ahead and search those out if you want quick ways to do what I'm about to show you. I'm going to show you the slow, painful way because that's the way you have to learn stuff sometimes, at least learn the foundation or the basics. Good news is things will automatically do this for you. You know, software programs will automatically do this for you in the future, but I'm pretty sure you're expected to know what's going on behind the scenes. So here's a scenario for you to think about. You have a WAN with 150 hosts on 3 networks. We're going to take Detroit, Chicago, and Indianapolis as our example. So you have 3 networks and you want 50 hosts on each of them. How do you do this? The network ID they give you is 192.168.123.0. And since I said it's a Class C network, that means it's going to be a slash what? A slash 24. Can we change that though? Can we make it another different type of slash? So let's take this one step at a time. First, don't forget, you need a network ID, which leads to no actual computer. It'll be the router itself. And then you'll need a broadcast ID. This is when you want to talk to every single computer in your network. Remember, a big point of having a network is so that you can have a network administrator control things from just one computer. He can speak to all computers from there, and that makes life so much easier. So as we start to chop this address range down, keep in mind for every subnet we have, we'll have to have a broadcast and a network ID. And what I just said answers this question right here. All zeros is a network ID, and then 255 is the broadcast ID. And we're talking right here, we're talking a C-class subnet, so that's why the X's. And I put X's just so you don't have to think about what those numbers are. Since we're looking at this range, 192.168.123, those are the numbers right there that would be here. If I subnetted it differently, then I would be moving the zeros and the 255 over. And it doesn't always have to be 255 or 0 because we can have uneven octet splitting, but more on that later. In this case, you divide your network into 4 subnets by using a subnet mask that makes the network address larger and the possible range of host addresses smaller. So in other words, you are borrowing some of the bits usually used for the host address. So you're going to hear that term a lot, borrowing bits. What do you do with the bits that you borrowed? You're going to start using them for the network portion. So let's change our subnet mask. Instead of doing the /24, we're going to do a /26, and that's what it looks like right here. We have now a 1 and a 1 right where it used to be a 0. Make sure to pause and write answers down here and keep notes, of course, so this stuff can sink in. So now we're using a subnet mask of 255, same, 192, and your 192 address will be split up into these 4 networks. Now you might be a little confused here because the original directions were we have 3 networks, 3 cities. Well, there's an aha moment coming any moment now. Here's your new range for each of the networks. And remember, this is a range because 123.1 means that this is host computer number 1, node number 1. It's not the network ID, right? And it'll actually go up all the way to .62, in which .63 would make all the host bits flip to 1, which is the broadcast ID, which is the thing we cannot use, right? So that's why there's a 63 coming next, and down here, the 64, we don't start with 64 because then that would be the network ID. So here's range number 2. The first computer in range number 2 is .65. And this bad boy will go all the way up to .126 in this particular subnet. So that was really the tricky part to me. All you have to do is find the network ID and the broadcast ID, and then you can have your range after that because it's just -1 and +1. Right here, I'm saying that the tricky part of this, to me at least, was I just didn't get how a network ID is supposed to have all zeros, and then here a teacher is telling me that 192.168.123.64, right, the number right before this in the range, the number right before this. How is .64 a network ID? It's not 0, so how can it be a network ID? Well, in order to understand this, you have to see the binary. I wasn't lying to you. Network IDs do have all zeros in the host portion of their bits. And if you can't see the binary, you would not realize that. So I hope that was a good enough explanation for you to answer this question correctly. Tell me what the network ID for number 3 here and 4 is. And it's really easy, so you could do just -1 to tell me what that is, but you can also do it in the binary. I would love to see the binary, and you would probably love to see the binary too, just to feel comfortable with what's going on. Let's take our example of 64. So to make 64 in binary, I have my little table down here, right? So I would have a 0 here, and then a 1, a 0, 0, 0, 0, 0, 0. Those are all zeros. I am a teacher that doesn't lie to you. This is the network ID. And that would be the same for the number 128. Just 1 here, all zeros. I got myself a network ID. And there's a few numbers like this. Ultimately, you'll probably memorize these if you're working with it all the time. But 192 is another example of a number with multiple zeros after a 1. And you know what? I didn't even get to the good part yet. The magic of having a network ID like this is we can use these network IDs in a routing table to help people find the right network they're looking for. So if you are sending an IP packet, if you are looking for a router and you don't know what one of these networks has that router or has that server, if you're looking for a server, you don't know which one of these has that IP address, well, you're not going to go to them all and ask if the computers are that number, if the node is the exact node you're looking for. What you're doing is you're looking for the network that IP is on and then looking for the particular destination address that you've been traveling all around on the internet looking for. So here's how you do that magic. And the students who remember my public key lesson, that is a great lesson to go through all the details, know what's going on, and then don't worry about memorizing it all. Just know that there's some math magic going on that helps us make sense of this world. So let's take the first subnet for an example. We have a 192.168.123 network with a range of 1 through 62. So let's say I send a packet with the destination IP of this, okay? I'm looking for 192.168.123.32, okay? Where is this server with my Fortnite game on it? Turn all these numbers into the binary. And for the sake of this example, I'm going to make it really easy so you can clearly see what the network ID portion is and then the host portion. But the cool way routing tables works is we should be able to use any subnet mask to ultimately find this packet's home. So in total, here's that IP address, and then here's a subnet mask I'm going to use. Pretend I'm a router, and this is my subnet mask. So with that knowledge, the IP and subnet mask will put the peanut butter and jelly together. I don't know which one would be peanut butter and which one would be jelly. I think most people like peanut butter, but not all of them will eat jelly with the peanut butter. So maybe everybody has a subnet mask, right? Has the peanut butter, but then not everybody enjoys jelly. So this destination doesn't belong to everybody. It's a unique thing. Or you could just completely flip that around because some people are allergic to peanut butter, so some people really don't want this destination address coming into their network because they don't have that in their network. Anyways, what you're doing with these numbers is what's called an AND operation. So you're going to look at every bit, and only if there's a 1 and a 1 will the bottom bit be a 1. So you go through that whole process, and you come out the other end with this number. What is this number? It's the network ID. This is the number where that IP address should be living in. So I put the dotted decimal form right there. So we're looking at a 198.168.123.0. And that makes sense because up here I talked about this being a range. So yes, an ID has zeros at the end. Sure, there's zeros right here, but those don't matter, and I'll show you why in a second. Just take a minute to soak this in. Maybe write it down. To understand what I just said about a subnet mask not needing to be the exact same subnet mask for the IP that it's living on, when I said that, you have to keep in mind that Aaron, this organization, is giving out these IPs using these ranges here. And Aaron's not going to give out a Class A IP address range where 10 is the network and then 00 is the host, and then you're going to flip that where 100 is the network and 0 is the host. You're not going to see that. If this bit was flipped right here and this became a 1 right here, well then that would be the network that this destination IP address is looking for. That one is really hard to visualize, so let's see if it makes more sense when I go over the code. The code that sits in the router to make sure all this works. Remember how computers work. They can only do a few things, and comparing numbers is definitely one of the things a computer can do. Because at the end of the day, they're not comparing numbers, they're comparing binary permutations. So they're comparing sequences of ones and zeros. And since we're comparing numbers, we're going to get to this situation in the code in a second where if a destination IP address is not on my network, I'm going to send it through a default route. And that default route will let that packet travel somewhere else, and hopefully it finds its mother, aka its destination. So here's my pseudocode, and if you've heard me before, I say the word pseudocode a lot because my joke is I want you to see the code, like the code that a programmer would be using to create something like this. And if you've taken my coding classes, you know there's like 100 different ways to code the exact same type of program. But I'm sure most people would tell you there's like a right way and 99 wrong ways. Regardless, I would like you to pause here and see if you could figure this out on your own before using only my highlighted hints as to what's going on, maybe? And now that you're ready for the explanation, here it is. So let's put something on the wire. How do we do that? Well, let's take an incoming packet with a destination IP that isn't in this network. We're going to AND it the subnet mask, and then we'll execute the code. Well, I might be a little confusing right here because when you're doing the AND operator there, the code is doing that. And in my example I'm about to show you, I was being less than random here because I'm going to go ahead and just flip one of the bits. That way we're working with numbers you're already familiar with.